Welcome to the DataStack Show. We are talking with a fascinating guest today. Another guest from Netflix, actually. We talked with someone from Netflix actually early in the life of the show and had a great conversation. And today we're going to talk with Viren. He actually created a technology at Netflix, open sourced it there, and then came back to commercialize it later in his career, which is a fascinating journey. And it's in the orchestration space, which is super interesting. And we haven't talked a ton about on the show, Kostas. I know you have technical questions. My question is going to be, orchestration tooling is not necessarily something that's new. So I want to know what specific conditions at Netflix were sort of the catalyst for actually building a brand new orchestration tool. Because that's going to be really interesting to hear, especially from the Netflix perspective. What problems were they facing? Where were they at as a company, et cetera? So yeah, that's what I'm going to ask about. How about you?
Many different things for different people in software engineering. And I think this is something that's going to be very useful for our audience that's primarily data engineers to hear about. So hopefully we're going to spend like a good amount of time like talking about the different flavors of orchestration out there and when and how we use them.
Absolutely. Well, let's dig in and talk with Viren.
Let's do it.
Viren, welcome to the DataStack Show. We're so excited to chat today.
Thank you. Thank you for having me here, Eric.
All right. So we always start by just getting a brief background on you. So could you tell us, where'd you start your career? How'd you get into sort of data and engineering? And then what led you to starting Orkes?
Sure. Yeah. So I'll keep it short, but like essentially, I spent kind of in my early days of my career, a decent amount of time working for firms in Wall Street, lastly at Goldman Sachs. One thing that was kind of the case with typically all the Wall Street firms is that data is their kind of secret sauce, right? Especially in today's world. At some point of time, I hadn't kind of itched to kind of go a little bit more technical, so went on to kind of work at Netflix, which was the early days of Netflix in terms of their pivot from being purely a streaming player and number one at that point of time to becoming a studio. And I got to work with some really brilliant engineers there, and thought like there might be an opportunity to kind of scale myself out further. Spend some time at Google afterwards, dealing with a couple of developer products, Firebase and Google Play, to be more precise. And then one thing that I had done while I was at Netflix was kind of had built out this orchestration platform called Conductor and open sourced it, and we had seen a great momentum in the open source community. And even from the timing perspective, and felt it was the right time. So, I decided to kind of, take a plunge, and start building out a cloud hosted version of Conductor, and started Orkes with a bunch of my colleagues from Netflix. And yeah, here we are. It's been a almost 3-4 months old journey now.
Awesome. Well, congratulations. You're sort of just starting out, but that's super exciting. Okay, I have to ask this question. What was it like going from Wall Street to Netflix? I mean, was there like both, just from a data standpoint, but also a cultural standpoint, it seems like that would be a huge shift.
Yeah, absolutely. Like, if you think about engineering practices, for example, in Wall Street, right? Like, and Goldman Sachs, to be honest, right? Like, prides itself on being very forward-thinking, very tech-oriented firm in the Wall Street, and they rely a lot more on open source compared to anybody else.
Oh, interesting.
So in some ways, like engineering wise, kind of the tech stack and everything was similar, but how you think about kind of building things is very different, right? Like when you think about companies like Netflix, right, for example, or any tech companies, right? The pace at which the innovation happens is very different, right? It's very rapid, because here it's all about like, you have to be always innovating for the future, not for the current problem. So that was one thing. And second, in terms of like just the cultural aspect of it, right? Like if you think about it, tech companies tend to be a lot more open to new ideas, taking bold risk when it comes to technical investment, and then you essentially hire the best engineers and let them do their best, as opposed to kind of manage them from top down. So I think in terms of being able to do things, there was a lot more freedom, I would say. And also kind of the problems, right? Like you are no longer at the second or third line when it comes to working with the customers. And in Wall Street, you never work with the customers directly. Here, you directly work with the customers at times, depending upon the team. And you can see, and more importantly, when your family or friends ask, what do, you can tell them, I work for Netflix. And if you do this, this is what I did.
Yeah. Yeah, that's a lot easier at like dinner parties and cocktail parties.
Absolutely. Yes.
Very cool. Thanks for sharing some of that insight. Okay, so let's go back to Netflix. So what a fascinating time to be there when Netflix is going, sort of from a content aggregator and distributor, say, to being like a producer. Those are very different kinds of companies. And you said Conductor was kind of born out of that transition. What were the challenges that you faced as an engineering team that, sort of were represented in that transition?
So I think basically, I joined a team and our mission was to kind of build out the platform team to support the entire content engineering and studio engineering organization at Netflix. And Netflix, as you know, right, like has historically invested very heavily into microservices. Almost they championed microservices, right? And one side effect of microservices, as you could see, is that like, you end up with so many, this little kind of services with a single responsibility principle, right? But now, as your business processes get more complex, and this started to become especially true in the studio world, where you are not only dealing with the data that you own and the teams that you work with, but also external partners, external teams, really long running process. Like to give you an example, right? Like before us, it could take months before a show is completed, right? Like in terms of its entire production process. And you are managing these long running workflows all over the place. And this was one of the need that we wanted to have. And, as they say, right, like, sometimes the things that you innovate is not because, you thought of a cool idea, but rather there was a problem that was hitting you directly, right? And I was responsible for, traditional way of solving this problem will be like, you just end up building an enterprise service bus or a pub subsystem like SQS, right? And build everything on top of it. And that's exactly what we were doing. What we realized was that it worked well when your processes were very well defined and were kind of simple enough. Now, there were two things that were happening, right? One is that the number of processes were exploding. The second thing was that Netflix is not a traditional Hollywood studio company, right? It's a tech company, and they think about problems in a very different way. You also want to experiment with processes and see what works, what doesn't work, which means you want to be able to rapidly change things and test it out, saying whether this works or not, right? And so that agility was another situation, right? Like one thing that we absolutely did not like at Netflix was building monoliths. But what we realized was that we were building distributed monoliths because now the code was there all over the place. And one change meant I had to go and talk to 100 engineers, beg them to prioritize the change. And if a product manager wanted to change something, you would go and talk to 100 engineers to figure out how the process works.
Wow.
And this is where we thought like, this is not going to scale. And we had to build something. So that's where basically, we started thinking about Conductor. We started with a very simple use cases and it evolved very organically over the period of time.
Can you give us an example of just one of those simple use cases and how it sort of solved that across like some specific microservices?
Absolutely. So like very first use case, right? That was very simple. Like it was basically, you have a bunch of images that, you have received from marketing agency or, you have used ML to produce from the video files. We wanted to encode them in different formats, one for browser, for iOS, for Android, for TV, and then deploy it to a CDN. Very simple, right? You take an image, encode, deploy, and then you test and see, what works, what doesn't work. Does the format, is the PNG works better on iOS versus Android? If not, redo the same thing, the entire process. Sure. And it looked very straightforward and simple application that we thought would be a very good test. And that was the very first use case that we actually built Conductor for.
And so how did Conductor change? What was the process before? And then how did Conductor change it?
So if you think about the original process was this, right? Like that there will be an application that is responsible for publishing images. So, now the person who is building the application is not necessarily the audio engineer or video engineer, right? Or the image or the, engineer working with the images. So now it's a different team. They have a microservice. So you call a microservice to say, give me an encode in PNG format. Then you wait. We relied very heavily on Spot resources on AWS, and Netflix has done some fantastic work there. So it could take some time. You wait for it, it completes, then you go and deploy. What if your deployment fails? You retry, and then this thing works, but then your product manager comes and says like, hey, but what we realize is that this particular format does not work very well because latency issues, maybe because quality issues, whatever. Can we change the encoding? So you go back and change your code, redeploy, or you go and ask that engineer who works on the encoding team to say, hey, what's the API endpoint where I can use it to encode in different format? And you redo this, right? Like it's a very intensive process. Yep. And sometimes we were changing this in multiple times during a week, right? To see what works, what doesn't work, getting feedback from the users from A/B test and whatever not. Or now I want to deploy 20 images instead of 10 images because I have got more A/B tests to run. So those were kind of starting to become a little bit unmanageable. And this is a very simple example, right? But if you put something in between to say, okay, depending upon the country now also, right, where we are going to launch the show, I want to have a different format because some countries would probably need a lower bandwidth images, right? It starts to get very complicated, and as you could imagine, right?
So interesting. So in the new world, Conductor sits on top and sort of interacts with all of the various microservices to streamline that process.
Absolutely. So like in the new world, essentially what happens is that instead of writing all the code, what you are saying is that I have a microservice that can do image encoding, and I have got 10 different one of them that each one is responsible for a different kind of format. And then as an engineer or a product manager, you basically work with your product manager and say, okay, what's the flow that we want to see, right? Like, and it's like, okay, if the country code is this, these are the set of images that we want to produce. This is the CDN location that we want to produce. You essentially build out a DAG, right? A graph of what the whole thing is going to look like. And when a new show is ready to be, published, you call it, it does everything. You want to change something, you go back and update the workflow because the microservices are there, right? They are not changing as much. It's this flow that you are tweaking and fine tuning and, and optimizing for. And now as an engineer also, right, like at some point of time, you can give it the whole thing to the product manager and say like, why don't you just try it out if you want separately? And if you find something that is missing, I can build a microservice and then you can plug it in, right? And it becomes a lot more tight coupling, or rather tight conversation between the engineer and the PMs. The expectation is not that PM is going to go and manage these things. Engineers are still responsible for building these things, but your work gets simplified, right? And now you don't worry about, oh, I have to put a retry logic. That's taken care by Conductor. Conductor will take care of retries. You just write saying you basically write, or let me put it this way, right? You write for best case scenarios, and Conductor takes care of all the edge cases, the failures, retries, and everything else.
Fascinating. Okay, I have one more question because I know that Kostas says his mind is probably exploding with questions. And this may sound funny, but was it an immediate success in terms of adoption, or did you have to? Because sometimes at those things, it's like changing, even if technology makes things better, like adoption can be difficult, or like, oh, we don't necessarily want to change the way that we do this, or like it's actually work to migrate our whole thing. Like, how did that happen culturally inside of Netflix?
Actually, that's a very interesting question, because Netflix famously has the culture of freedom and responsibility, which means, you don't have mandates to say, hey, you have to use this framework. Right. You know what frameworks are there and you choose what you want to use.
Sure.
Right?
Yeah. It's like self-serve with all these options.
Exactly. Yeah. And nobody's going to tell you, why did you, choose this, right? It's up to you to decide and to get the job done. So that becomes a very challenging thing, that you can't just build something and get a VP or director to go and say, send out an email to everyone saying, we didn't build this fantastic new framework, everybody must use it. Not going to happen. So now Viren has to go and talk to everyone, right? So one approach that we took right from the beginning was that we ourselves were developers, right? So we understand the pain points of developers have it. So we built it very much like a democratized version, right? We did not have a product manager. We made a very conscious decision that we don't want to have a PM kind of shepherding the product, but rather let's talk to engineers. What do they want? So like every feature that we built was out of a necessity and a recommendation or a need from another engineer. And that was one thing. Second thing was we kept it very agile in terms of its development, rather than trying to think about we have to build a very perfect system from the get-go. We made it functional, and we built the resiliency and everything kind of along the way. As we were testing with the internal users, that was another way kind of we kind of try to evangelize within Netflix itself. And of course, like, there were always kind of skeptics or people who want it a different way, right? And we try to keep it like as open as possible. That was one thing. So the side effect of that is, like, if you look at the current repository also, it's a very flexible system. It's pretty much plug and play. You can plug and play, like it's a Lego block, right, in some ways. And that was one of the reasons why it turned out to be like that, because we wanted to be able to satisfy as much as possible. Like in some ways you can think about, right, that it increases the complexity and effort, but the advantage there was that everybody felt that they had a stake in the game, right? Most important thing was to get them invested in the product, and then you have your customer who is happy.
Super interesting. Okay, I lied. I have just one more question. I promise, Kostas. Because I'm just it's always fun to hear about how these projects sort of form inside of a company like Netflix with such an interesting culture. I know that microservices were a catalyst for building Conductor to sort of make them easier to interact with, but it wouldn't surprise me if actually microservices proliferated at a higher rate after people started using Conductor, because it was easier to manage a lot more. Did you see people building a lot more microservices?
Absolutely. Because see, like what happens is that if you don't have something like Conductor, then you tend to take shortest path, right? Especially when you are under time pressure or you have to deliver things. So if you were to build something of a complicated business flow, building 5 microservices, writing orchestration logic on top of it, and making all of these things work is more time effort versus putting everything into a monolithic block and get it out. So in some ways, Conductor kind of encouraged people that, like, break it down, because now you have another side effect of it, right? The moment you break it down, you have a lot more composability to be able to change flows and everything. So that was one thing that really kind of inspired people to do that. The other thing was that we built 2 critical aspects that everyone wants, right? Traceability and controllability, right? Like you can actually trace and the entire execution graph visually and see the graph. They had just turned out to be a sleeper hit for us. Like I had never thought that this is going to be the killer feature. We thought the killer feature is going to be distributed scheduling, but no, killer feature was that UI that people loved it, because I could see exactly where things was wrong. Because that's the problem you face, right? You have to go and look at the logs everywhere and see what's going on. Versus I have a UI, I just click on it and say, oh, this is what's wrong. Go fix the code, retry, and works. So some of it was like that also, that just encouraged. Now, if you use Conductor, you get these features that you otherwise wouldn't get it, right? And that encouraged people to write more microservices.
So, Viren, I have a question about the open source side of the project. So you, how soon after you developed Conductor internally, you open sourced the project?
I think it was about 6 to 8 month journey. Like, we took it to the place where it had enough features that it did not look like a toy project. We also had to decouple everything from internal non-OSS side of the world, and we wanted to put together some amount of governance process also, right? Like my team, we did not have any open source product that we were managing ourselves, so we had to kind of figure out learning from other teams in Netflix, right? So yeah, overall it took us about 3 quarters, and the day we decided that we want to open source, it took about a couple of months to get everything ready, right? Prepared, legal reviews, patent reviews, and all of these things.
Yeah, makes sense. And how long it took after you open source the project to start getting engagement and creating a community of adopters of Conductor out there?
I would say, what I've seen is typically, you have this initial bump, right? Like that, you open source, people are excited, they want to try it out. So there was this initial bump. Then it starts to taper off because, there's nothing new there. And it kind of stayed there until very recently, I would say. So what was happening was that, what we had done was that, like, we were doing meetups at Netflix. about Conductor. Also we're talking about Conductor in other meetups and everything. So, as we kind of talk to people, it started to kind of grow the momentum. The other thing was like, if the community is always the consumer of the product, right, it does not grow the community well, right? Like we kind of also made it much easier for people to contribute back to Conductor. And once people started contributing back, right, it started to grow further. Because now again, like they have a stake in the game, they have the ownership in the product itself because they have contributed.
Yeah, of course, makes a lot of sense. And do you have any like use cases that came out of the open source community that surprised you?
Oh yeah, absolutely. So one use case that if you ask me today, right, without learning about this, I would not have even thought about it in my wildest day, right, was security. People using Conductor to orchestrate security flows, things like threat detection, things like, for example, let's say you upload a file in S3 bucket. Typically you want to run some processes and checks to ensure that you wouldn't upload a secret by mistake or on purpose or whatever, right? Or there is not a virus and you are going to run a bunch of workflows around it, right? To some automated, some manual. And this is all done by folks who are into the security space, not necessarily writing microservices, but Conductor turned out to be a very good use case for them. So this was one thing that surprised me, that there is a strong use case here that I had not thought about it.
Yeah, that's so fascinating. Like I would never think about it, to be honest.
Yes, exactly. But then more I think about it, right? Like these are long running flows, right? Like it might take some time to scan object. If people are uploading thousands of objects in S3 bucket, for example, right, it may not get a real-time treatment. So you need to have a backlog queue, and if you find something, maybe somebody has to do manual intervention to verify, right, then you have a human process involved in it. You send an alert or something, wait for someone to reply. So all this flows becomes a pretty good use case. That's what I realized.
Yeah, makes sense. Okay, I'll probably get back to more open source and company also related questions a little bit later, but I'd like to discuss with you about what orchestration is. It's a term that it's being used like in a lot in engineering, in software engineering, and not necessarily like in every, let's say, discipline the same way, right? Like we have orchestration that data engineers are talking about. We have orchestration that has to do with microservices. We have workflow orchestration. Then we have orchestration on Kubernetes, and probably like many other types of orchestration out there. Can you help us like define, let's say, a taxonomy around orchestration tools out there and understand better like the differences between the different tools and the use cases?
Yeah, absolutely. Yeah, I mean, as you say, right, orchestration is an overloaded term, right? Like it has different meanings to the people and use cases, right? And having spent some time on this space, right, like what I've realized is that, like, essentially, if you look at from the persona, right, like who is looking at the word orchestration, there is a kind of a different meaning to it, right? And like if you go in a top to bottom, right, in a company. So if you look at people, let's say people on the business side, right, business analysts, product managers, who are dealing with the business processes at a high level, right? For them, essentially, if you think about, when they think about orchestration, they are looking at how various, business components are getting orchestrated, right? So like in an e-commerce company, this might be, how am I orchestrating between my payment and shipping and delivery and tracking systems or fulfillment services and things like that. But again, this is at a business level, and again, when you think about also measuring the output of the orchestration, right, SLAs, any other key metric that might be defining, right, they look at it from that perspective also, right, like the time it takes to complete certain activities, mean time for failures and things like that, right, how often they fail, and where are the optimizations that they can make based on those data points, right? They are not the ones who are actually building the systems. Then that typically goes to the backend engineer, and when they describe the same flow to the backend engineers, essentially for them, you could think about these individual things as kind of either microservices or other services, which, for the lack of better word, right, we can just call it microservices. And for them, when they think about orchestration, right, it's about, I have a bunch of microservices and I have to build a flow around that. How do I build that? But now what I am looking at as an output from this is, how do I handle certain things like, for example, in a distributed world, services are going to fail. Services are going to, have a different SLAs. How do I handle failures, retries, different SLAs across them? I want to be able to run certain things in parallel, so I can optimize my, time it takes to kind of complete the entire process, or resources and everything. How do I kind of achieve that? And if I'm doing certain things in parallel, how do I wait for them to complete? Because you can't just always do that otherwise, right? So that's how a backend engineer is thinking about orchestration. Then if you take it further down one level, right, in terms of the platform side of it, right, then, and you look at, even zoom into this, let's say an individual microservice. This microservice is typically getting deployed onto a container these days, right, or a VM, or even a bare metal machine somewhere. But you are not deploying one thing, right? You are deploying kind of whole bunch of things, and typically you don't only deploy a service, you deploy a service with sometimes, at least in the initial phase, right, some more semantics around it, right, like the networking configuration, databases and everything. And that starts to get into more of the continuous deployment side of it, right, which is where the container orchestration, for example, has become very mainstream, with Kubernetes, and Argo is another one, for example, there, right, where essentially it doesn't matter what you are doing, you have a piece of code that you are deploying and scaling out and scaling down, right? And that's what you are focusing on. That's another level of content orchestration that is happening. And just to go back to the backend engineer, right, like there are different flavors of backend engineers also, right? You have backend engineers that are working with product managers to build an application. You also have data engineers who are dealing with the massive amount of data and orchestrating, right? This is where things like Airflow, we have seen at Netflix, Conductor also is being used for similar purpose, where you have data sitting in different places and you are essentially orchestrating that, right? In a batch world, right? Like, you are processing data, aggregating that, putting into database, maybe training some machine learning model, making inferences, putting into database. The whole thing is basically a flow. And offline flow is very well orchestrated through something like Conductor or Airflow and similar systems. And a slight variation of this is kind of real-time data platforms where you still have flows, right? If you think about, right, let's say I click on a button in my phone or a website, and you are sending out a signal, right, an analytics data point back to the server. Now this has to go through kind of certain journey, right? Like you are waiting for it to do a streaming aggregation, but once it is aggregated, it goes through maybe a couple of other systems where either it is being used to do either further aggregation, get it into a more of an analytics store, or maybe you are doing kind of real-time model training through machine learning, right? So that's kind of the another flavor where there's no start or end of a workflow. It's continuously running pipeline, but you have a complicated flow that is built out. I think Kafka or Confluent has some tooling around that, but I think that seems to be right now still a very wide open space. I would say it's still an unsolved problem. How to do that?
Yeah, makes sense. So just to give like an example, because we have like our audiences, like primarily like people that are working with data and they are data engineers. What's the difference between like a system like Airflow and Conductor, and why I wouldn't use, let's say, Conductor, and I would prefer like Airflow in order to orchestrate my pipelines?
Absolutely. So like if you think about Airflow, right, from its genesis and the kind of use cases it solves, right, it's mostly about data, right? Like typically, you have data sitting in different buckets, or databases like Hive, and you are processing, right? And these are typically batch jobs that you run an hourly basis, maybe twice a day, 3 times a day, or a daily, and things like that, and runs through the data pipeline. The other important part of a data pipeline also is kind of the dependency management, right? Like you have to run in a specific sequence because your data at a given step depends upon the previous step. Also, rerunability in the context of data is very different from a rerunability in a microservices world, right? When you think about rerunning some data, you are essentially running data for that particular date or a time frame, right? And you're only processing that data alone. You're never processing the latest data. So that's kind of high level use cases that I've seen Airflow being used for. And it does well, right? Also, if you think from the users of Airflow, right? These are mostly people dealing with data. And the language of the choice today for that is Python.
Yeah.
So, Airflow DAGs are written in Python, and they tend to be simple in nature, right? Like you have sequence of things that you do. Sometimes you fork and you are done with it, right? These pipelines are very stable, very fixed. You don't change them every day. You don't do A/B testing of this pipeline. It doesn't make sense to do that, right? Conductor kind of goes on to the other extreme. It's more about flows which could be running for very long period of time, say months at end, or very short one where you complete the entire flow in few hundred milliseconds and everything in between, right? But instead of running few executions a day, you could be running few hundreds of millions of executions per day, or even a billion executions per day, depending upon your use case. So, the scale side of it is very different. At the same time, a typical workflow is operating on not petabytes of data. A step in the workflow is typically dealing with a finite set of data.
Yeah.
And sometimes you do, like for example, one use case that we had on Netflix was the processing the video files, and a raw video file could be petabyte in size.
Yeah.
In that case, you are still processing for a longer period of time. The other thing is that Conductor is very general purpose, and it is meant for pretty much the entire spectrum of audiences, right? So it's very much language agnostic. We had workflows where one step was written in C++, another in Python, and third one in Java, and so forth. So it allows you to kind of mix and match depending upon the owner of the step in the process. So Conductor becomes very useful in this kind of scenarios where you have a very heterogeneous environment, and the scale is another thing.
That's very interesting, and it's like something like that. As you were talking about Airflow and Python, like I wanted, like it came up like as a question to me. So Conductor is written in Java, right?
Yep.
How easy it is? I mean, you gave an answer, but I would like to hear a little bit more about this. Like, how easy it is, like, for example, for a team that it's primarily using Golang, for example, to create microservices, to employ like an orchestrator that's written like in Java, because probably you're not going to have a team there that knows Java, right?
Yep.
How does this work, and which team is usually like responsible for that? Is it like the platform team? Like, who is responsible for managing, deploying, and taking care of the orchestrator?
So let me ask you the first question, right? So like, I think the way Conductor works essentially is it exposes its API through HTTP and gRPC, and that's how it becomes kind of language agnostic, right? So let's say if you are a Golang shop, you are writing your microservices in Golang, and you are building your orchestration flow in Conductor. Conductor also provides client API. So like there are two parts to Conductor. You have a client or SDK, and the server side. Server side is in Java. SDKs are written in different languages. So I think there are three right now: Java, Python, and Golang. So you use that SDK in that particular language to interact with Conductor. And gRPC is great where, if you want to get bindings for Rust, for example, right, you can do that using gRPC compiler. So that's kind of how it works today. And that's why it is language agnostic, because, the entire model is that way.
Yeah.
The second part, who runs Conductor? It's a very interesting question. I think I have seen kind of both side of it, in the sense that where there's a platform team that is responsible for running Conductor. This was exactly what we were doing at Netflix, and my team was responsible for managing as a platform for all the teams. But that was the model at Netflix, right? You have a platform team, and this tends to be a lot more common in tech companies where you have a platform team responsible for all the components, and everybody else uses that, right? We have also seen the other side where you have business teams that owns the entire stack by themselves, and then they are kind of responsible for running Conductor on their side. So I think it in some ways goes back to the culture of the company, right? How they are formed, and what's their kind of usage model. for all the maintaining the products, how that works.
Yep, that's interesting. And probably not solved yet. I mean, it, as you said, like also has to do a lot like with the culture. I mean, I hear a lot about, you know, like platform teams, but it doesn't mean that like every company out there has a platform team, or like you can just like wake up one day and be like, let's have a platform team now.
Yeah, I mean, there are two challenges, right? Like building a good platform team is not easy. Hiring good platform is even more difficult. Like hiring engineers are difficult. Now we're talking about hiring platform engineers. Like you just made it exponentially harder to, you know, build a team, right? I think in reality, like what really works well is that, like, you know, if you treat your platform team as a mini cloud team in your organization, right? So today, for example, if I want to use an RDS database, right, from AWS, I can go to console, provision one for myself and start using it. And AWS takes care of everything else for me, right? Provisioning, you know, backup, restores, and everything. So, you know, if you end up building a platform team that can get to that stage where, let's say, any product for that matter, right, not just Conductor, that they are able to offer in a self-service mode, and they focus on building that platform out of it, right?
Yeah.
But then again, like cloud companies are offering more and more of these things, right? So, you know, the line between the internal platform team and a cloud provider becomes thinner and thinner day by day, right? Yeah.
100%. All right, so let's go back to building a company, right? So you open source the project, you started having like some traction out there, and at some point you decide like to build a company around the core technology. My first question is, when we are talking about an orchestrator who is going to be interacting with microservices, and as you said, there are like use cases there where there is like you might want to run like millions of like interactions, and the latency should be like super low, right? How do you build like a cloud service around that, and you make sure that the microservices themselves that the company is building are like sharing the same resources, let's say, or the same networks, or like all the stuff that's needed there to make sure that the latency like remains as low as possible?
Yeah, I mean, I think the key to that is essentially your deployment model, right? Like how are you deploying those things? Like, you know, lower the latency you want, right? You want to be as much co-located as possible. Yeah. So like essentially what we have done is like we essentially have built out like two different models of deployments, where one deployment is where you have kind of Conductor running in a separate VPC, and your microservices in a separate VPC, and you have VPC peering that allows you to kind of communicate with each other, and you try to kind of keep the affinity between availability zones, so you know your network does not go through very heavy kind of you know hops. The second model where you want really low latency, right, is sometimes to kind of deploy Conductor inside your own network, as close to the microservices as possible, reducing kind of network, because now we are talking about, you know, few tens of millisecond latency differences, right, as possible, or even embed. Like the beautiful thing about Conductor is that, you know, it can run in a cloud environment, handle billions of flows, if not billions, every day. Or you can also embed it inside where you are running with a very low memory footprint, pretty much running in the customer's like, you know, edge environment, right? Like small deployments. So, you know, you essentially have to kind of make those trade-off decisions to figure out what are your requirements and how you deploy that thing. And to be honest, like this was something that we had to kind of think it through and figure out exactly how this is going to work, and come up with a solution there. But this always is an interesting challenge to solve.
So how is the product experience different between the two deployment models? And the reason I'm asking is because, and Eric is probably aware of that, because at RudderStack, like there were multiple different deployment models, although like for different reasons there. It wasn't that much like the performance. It was like, in many cases, it had to do with like, let's say, compliance. But building like a product that has like a consistent experience, regardless of the deployment model, like super hard. So how do you approach this problem?
So I would say, like, when I think about the end users of the system, right? Like I would say there are kind of two groups, right? So there are the engineers who are actually using the product to build the applications, right? For them, there should be no difference. Like, they are still dealing with the same set of APIs and same set of constructs and everything. If they were to go to UI, you have a URL where you go to UI and look at your workflows and manage everything, right? So that experience must be consistent no matter how things are deployed. The second set where it matters is the people who are actually responsible for the operational aspect of it, right? This could be a platform team, DevOps, SREs, and this is where I think the key difference comes, right? And it's very similar to running a relational database in a VM that you have provisioned yourself versus running something like RDS, right?
Yes.
Where a fully hosted service gives you an experience where essentially you don't even need that team. Things are taken care for you, right? Like it scales automatically for you. You don't have to worry about backups, what kind of database I should be using, if I need to get this performance or whatever not. You specify how much capacity that you want to run with, and system kind of scales for you, right? The other option, essentially, when you are running in your environment, right, you are also making those decisions by yourself now that, how big the instance should be, where should my backups be, and if something goes wrong, how do I restore from the backup? And I'm also responsible for my cost now, right? Like I can't just run a 1,000 node cluster without having that show up on my annual or monthly billing from AWS or Azure or GCP. So I think for those people, I think the experience becomes slightly different. I think ultimately the goal is still to be kind of make it easy in terms of the UI interactions, like, the console side of the world, right? Where if you are dealing with the Conductor console in the cloud to say, provision me this cluster, this is where my backups are, and restore and everything, it should be as frictionless as possible. Versus saying that, oh, here's a backup, you download it, run this command, just make it available. So that part is, I think, where the challenges are.
Yeah, makes a lot of sense. And how, I mean, you started, you were going through like your journey, and you talked like about the differences between like working in the financial sector and then going like to a B2C company like Netflix. But if we take it like from Netflix until today, like you were at Netflix working like with your customers being like inside Netflix, obviously. Then you open source the project, and suddenly like you had like a much more open, let's say, platform to experience there, because people were like start using and giving feedback. And now you did another step forward and you started the company. So how does it feel, and like what's the difference between like these steps that you had to go through?
I think, see, there are some things which are common. Like, for example, you still care about the community. You are still kind of working with the community, trying to build the community and grow the community. That part does not change much. Product, in some sense, also, right? Like you have the same amount of focus, whether you are internal or external. One key difference here is that internally, typically, sometimes, you have some other pressures in terms of, I need this feature because, we have this thing that is coming up, right? So, you prioritize. As a company, your prioritization has a different kind of way of thinking about it, right? It could be depending upon the customer pipeline, the features, and things like that. The second thing is that as you kind of build a company, right, like you cannot just think about product alone. Now you also have to think about everything around it, right? Like about the company, your investors, your customers, and especially in a startup environment, right? You are the engineer, you are the customer support person, you are the marketing person, you are the revenue officer. You are playing pretty much all the heads, right? So, you are doing probably 10x amount of work.
And you also have to make money, which is also like an important
absolutely.
All right, that's awesome. Like, one last question from me, and then like I'll give the microphone to Eric, which is like a little bit of like a technical question, but we talked about orchestration, and we're talking about like orchestration of microservices, right? There is like another kind of, let's say, like computation platform or model that's like becoming like more and more popular lately, which has like to do with edge computing, where you have, let's say, these like functions that are pushed to the edge and like executed from there and all that stuff. Do you see any kind of like opportunities there for orchestration platforms to work in such environments? And if yes, how?
Actually, that's an excellent question. And to be honest, there is a huge opportunity there. And the reason is this, right? That what is happening is that as kind of, and this is again, like, my interpretation, right? So I could be 100 miles off from the reality, but hardware has become a lot more powerful, right? So there's a lot more opportunity to kind of push a lot of processing closer to where the customers are.
Yeah.
And this could be, for example, in the embedded devices scenarios, right? Where like, you are not running in cloud, the whole thing runs on a customer environment, like sometimes on premise, for example, right? And, if it does one thing, that's fine. But usually, again, like, you have multiple things that you are coordinating and orchestrating against, right? And the concerns around reliability, fault tolerance, retriability, failure handling, they do not go away, right? Just because you pushed it to customer environment.
Yeah.
But it also now poses a challenge that you have much less visibility and control over this environment. So you want this to be even more reliable and be able to handle more failures compared to anything else. So in some sense, that's a huge opportunity. And at the same time, there are some constraints, right? Like, even though hardware has become powerful, you are still constrained with the memory, for example, right? Footprint, amount of components that you can load, because it's also running other things, right?
Yeah.
It's not just doing orchestration. So, but to be honest, we have seen use cases for Conductor in this space, and there are some customers using in that particular area.
Oh, that's very interesting.
Yeah.
And do you feel like there are also changes that need to happen in how, let's say, an orchestrator is architected in order like to be more efficiently working with the edge computing environments, or we are fine with how like Conductor was like designed and implemented so far?
I mean, no, it needs some changes, right? Like for example, a few things, right? Like you don't want, like if you're running a cloud, right? You can have a Cassandra and Elasticsearch and a Redis and few other components working together, right? And that's completely fine, because you have all of these things at your disposal, and you can orchestrate that. The moment you put it in the edge environment, you want a lot more self-contained systems, right? So you are kind of almost going back to drawing board and see what are the bare minimum components that you want, what can be run as an embedded mode, find the alternative and plug in there, right? One advantage that we had with Conductor was that because it was designed as a modular system from the beginning, it just made it possible to say, okay, we cannot use Elasticsearch because it's just too expensive or not possible to run in a edge environment. It should be replaced with this embedded database, right? And you have to implement those interfaces and get it done. That was an advantage, but as you say, it requires changes, right?
Yeah, awesome. Yeah, that's very interesting. Hopefully we'll have like the opportunity in the future, like talk more about that stuff. Eric, all yours.
This has been such a fun conversation. Unfortunately, we're really close to time here, so we only have time for one question, although we know that I always lie about only having one question. But Viren, I think in many ways, a lot of us who work in the tech industry, sort of being at a company like Netflix, being instrumental in building a technology that sort of solves a major problem, and then goes on to be open source. And then I think, for some of us who are entrepreneurial in nature, like actually starting a company on that, I mean, A, congratulations. That's really just an incredible journey. But B, I think just it's sort of an aspirational story for a lot of us, right? Do you have any advice, for people who say, man, that's sort of like the pinnacle of, the experience of being involved in engineering and cool open source projects and solving problems? Like, I would just love for you to talk to maybe some of our listeners who are like early or mid in their career and give them some advice that you learned along the way.
Yeah, sure. I mean, I'm still early in my journey, so we'll see, how that kind of ends up being. But like, here's what my thought process was, right? Like that, you can keep doing the same thing and keep polishing. Like, you can go from Netflix to Google to, somewhere else like Meta, for example, and keep doing those things, right? But in the end, the way I think about it is that, like, unless your career progression gives you a kind of a step function, right? It's not worthwhile, and you have to look for those step functions, right? So and that could be, for example, learning new technology, coming up with some new frameworks, evangelizing those things, and what's the next thing after that, right? Like, it's maybe to productize that, right, and see how it works. And it's a very different kind of a experience, right? Like, there's one thing about building a product where you are dealing with your IDE and compiler and breaking your head with bugs, and it's totally different ballgame as compared to that in terms of how do you go about raising money, right? Because now you don't know, actually, even before that, right, you don't start a company by yourself. You have to also find a co-founder. So first you have to convince your potential co-founder to say, hey, this is a great idea. Once you convince them, you have to go and find an investor, especially in the enterprise world, right? Like, you can't bootstrap, you need some outside investment. How do you kind of show the value that what you are building makes sense? You have the right skill sets and pedigree to kind of go and build this out. So that's kind of the, like, the story, but how do you tell the story in a compelling way, right? That's the another part. And then finally, once you have that, right, how do you kind of go around building this out? Like, where are you going to hire people, right? Like, how are you going to scale and all of these things, right? And how are you going to find customers? What's the go-to-market strategy, and how do you actually implement? It starts to kind of get into that, right? So it's a very rewarding experience. Like, to me, when I was thinking about it, what I realized was that no matter what's the outcome, I'm going to come out on top. Like, that learning is going to be valuable. And either way, it's going to be super useful in the career.
Yeah, man, I think that's such good advice for all of us, knowing that, no matter the outcome, if you learn, that's the ultimate, that's the ultimate progress. So thank you for that. And thank you so much for really helping educate us on orchestration sort of as a category and all of the differences there. We had a great time on the show. Thanks for joining us.
Yeah, thank you so much. Thanks for all the insightful questions. Yeah, it was really fun.
Great. All right. That was an awesome show. I don't know if I have a really insightful technical or sort of data related takeaway from this show, so forgive me, but I just think it's really interesting to think about working on an infrastructure or on infrastructure at Netflix while they're transforming the company from being a sort of content, distributor to being a content producer. And it was actually fascinating to hear about that problem described through the lens of microservices, right? I mean, you wouldn't think about, in like a Harvard Business Review case study of like Netflix's pivot from, distributor to studio, like they're not going to talk about microservices, but that actually was a real pain point as they were making the transition. And so I just really appreciated that perspective. You wouldn't really hear about that particular specific flavor of technical challenge in the process of a transition like that. So it was really fun to get an insight there.
Yeah, and it seems that like Netflix is one of these companies that they are really fueling the next wave of innovation right now. I mean, there are like a couple of different products and companies that they are actually coming from Netflix, which is great. And it's like super interesting to see all these people, how they were together in Netflix, and now they're out there like in the market and like building companies and creating like new products. So they definitely did something right. And I guess the Harvard Business Review should look into it at some point. But outside of this and like all the very interesting like conversation that we had for the technical details of orchestration, I think one thing that I'll keep and I would really love to learn more about is like edge computing and orchestration, which is still like something, it's early for this kind of technologies, but I think we are going to be hearing more and more about that like in the future. So that's another thing that I'm keeping from the conversation we had.
For sure. And if anyone is listening who is with the Harvard Business Review, it's a little bit abnormal, but we're happy to do a cover story if you're interested. So definitely hit us up and reach out to Brooks if you want to talk about that. Lots of great shows coming up. We will catch you on the next one.